Hello students, welcome to the next lecture on this sequence. Today we will discuss about what is the monotonic sequence and its example. Myself, Dr. Garg. Now you can simply follow my this YouTube channel Dr. Harish Garg, where you can find the various videos on this sequence and the mathematics. What is the sequence? As we discussed in our last lecture, sequence is the set of the ordered numbers which is denoted by A1, A2 and so on. And the sequence is denoted by curly braces of an or are like here. If this series is my finite, then we call as the finite sequence. If it is infinite, then we call as the infinite series. For example, if you consider the set of the even numbers 2, 4, 6 and 8, and this the nth term of this sequence is denoted by an, and this is the sequence of it. Now since they are the infinite terms, so we can call as the infinite sequence. Based on this, we can define the formal definition of the sequence. A sequence is a function whose domain is a set of the natural numbers. So remember that n is my natural numbers like 1, 2, 3 and so on. This is the most important thing. Based on this sequence, we can define like of -1 raised power n and so on. Now again you can see this is an infinite sequence, so we call as here. Now our target of this lecture is to check whether this sequence of this or this are monotonic, increasing or decreasing. So for that we will firstly define the term called as non-decreasing sequence. It is also called as the monotonic increasing. So what is the meaning of the increasing? It means if I take the first sequence number as a 1, another number as a 3, another number, next number is 7, then 11 and then so on, or say 13, then 14, you can see these are my increasing sequence. The same definition we can apply here. A sequence an is said to be the non-decreasing or increasing whenever the next term is greater than of the previous one, or you can say an plus 1 minus an is greater than 0 for all n in the domain natural number. Another definition is we can say a sequence an is said to be the non-decreasing if the ratio of the next term to the previous term is always greater than 1 for all n in the natural number. Similarly, if you look about this, sequence is said to be the non-increasing if the derivative of this sequence with respect to n is my greater than 0. Then we can say it's a increasing sequence. For example, if I try to check whether it's a non-decreasing or not, we will apply that all these three methods. What is the an plus 1? So you can see an plus 1 is nothing but n plus 1 upon n plus 2. Now you can see after the calculation you will get here. Can this number be always be greater than or equal to 0? Yes. Why? Because n is my natural number and natural number is start from the 1, 2, 3. So it is always positive. So this number is always positive. So you can say this is a non-decreasing sequence. Similarly, look about the second method. So what is the an plus 1? So if you look about that, this is my an plus 1 over an. So if you solve them, you will see these are my sequence. Now how you can say this number is my greater than 1? So if you see, I can written this number as 1 upon n square plus of 2n. Now you can see n is my natural number which is always positive. So this number is always be greater than 1. Third method is you can take the derivative of this. So what is the derivative of this? Here you can see again this number is again you can see always be greater than of the 0 because this number can never be infinity. So it means it is a non-decreasing sequence. On the other hand, how you can see whether it's a non-increasing or you can say it's a decreasing sequence. So that's all the results are reversed. That is an plus 1 upon an should be less than 0. The ratio should be less than 1 and their derivative must be less than 0. So then you can say the sequence are my decreasing sequence. So check which of the following sequence are my monotonic. If yes, check whether they are increasing or decreasing. So let's start with the first case. Again we will apply these three methods are here. The first method is here. You can check what is the an plus 1. You can say this is a 3n plus 4 divided by 5n plus 12 minus here. You can take the LCM. Now you can open this bracket. You can see it's a 15n square. It will be cancelled out and so on. After the calculation you will get here. This number you always see is a greater than or equal to 0 because for all n in the natural number. So it means it is a monotonically increasing sequence. Look about this one. So what is the an plus 1 upon an for this? You can see this number is my here. Again if you divide them, you can easily see this number is my 16 over this denominator part. Again, this number is always be positive, so 1 plus something is always be greater than 1. So it means this is again a monotonic increasing sequence. The third case is you can take the derivative of this sequence, you can take the derivative as here. Again you can see this number is always be greater than 0 for all n in the natural number. So hence by each of the method you can get a sequence is monotonically increasing sequence. Look about the next example. So how you can see, so for this an we will try to find an plus 1 minus of an. You will get here clearly says that 1 will be cancelled out, half will be cancelled out, this will be cancelled out, and the last term will be cancelled out. The only thing is my here, which is always be greater than 0 for all n in the natural number. So therefore this sequence is a monotonic increasing sequence. You can apply the second method also. So if you want to find the ratio, again you will get as a greater than 1. But here you can't apply as a derivative of this. Look about the another one, check whether it's a monotonic increasing or not. So again we will start with the first method. You can take the LCM, you can see this number is always be greater than 0. If you apply the third method here, because it's a derivative, so you can see it's a monotonic increasing sequence. But here you should remember that the second method, that's a ratio is greater than 1 for the monotonic increasing, has some shortcomings. For example, if I consider the same example and we have discussed that it's an increasing sequence. So what will happen if I compute an plus 1 upon an? So you can see this number is 1 minus of this. So this number is always positive. So is less than 0. So what is the meaning of that? This is my decreasing sequence, but which contradict about this fact are there. So it means this second method will not always give you the right answer. However, if you consider the sequence instead of the positive, you can clearly say that it's a decreasing sequence. Why? If you take that derivative, it will give you my here, and you can see this is always be less than 0. So it means it's a decreasing. So if you try to solve this, again you will get as a decreasing sequence. So what is the meaning of that? If you consider the same number, one is a negative, one is a positive, that will not distinguish by the second method. So therefore I recommended not to use this method to check whether it's increasing or decreasing. So you always try to check whether it's increasing or decreasing by using this one. So if this condition satisfied, we call it a increasing. Otherwise this condition satisfied, we call as a decreasing sequence. Look at this, some more examples are there. We will try to cover the 15 examples in this video so that you may able to understand more clearly. So if an is this sequence, you can compute the an plus 1. Your target is to prove that an plus 1 minus of an should be less than 0. This is your target because of the decreasing. Now you can find the an plus 1 minus an. If you subtract them, you can see up to this will be cancelled out and the remaining part here. I can combine them, you will get here. I can apply the logarithm series, log of the 1 plus x, it is nothing but x minus x square upon 2 plus and so on. We can apply like here. I can open this bracket and take the pair of this. You can clearly say that this number is my positive, because if you take the LCM, it will be give you 4n minus 3 over 12 and 4. It is always be a greater than 0 because n is my natural number. So it means this number is positive. If I consider this as number and this is negative, it means this number is less than of here because of this negative. If you take the LCM of this, you will get here. So can you say this number is always be less than 0? Yes, because it's a 1 minus n. This denominator part is always positive, but this is always negative for all n belongs to the natural number. So it is a less than or equal to 0. Hence, it is a monotonic decreasing sequence. Look what the second type are there. How you can check whether the sequence is monotonic or not. Here, your target is to check whether it's a monotonic increasing or decreasing. It means your target is to check whether this happen or this happen. So let's firstly check whether this happens or not. So we will try to solve this with the help of mathematical induction. So what will we do? We can start with the n is equal to 1. So what is the value of this? So x2 is nothing but my here. We know the value of the x1. I can substitute this value. So clearly says that this number is greater than of root 3, because its answer is, so what is the x3? It's my x1. So x2 is greater than x1. It means the result is 2 for n is 1. Assume that the result is 2 for n is equal to k. Then we can simply multiply by 3 on the both side. Take the square root p. What will happen? This is nothing but x plus 2. This is xk plus 1. So therefore the result is true for all the n belongs to the natural number. Hence the sequence is monotonic increasing. Look at the similar kind of the second example. So whether so your target is to prove that it's an increasing sequence. Again we apply the principle of mathematical induction. If you take n is 1, it is my x2. This is 6 plus x1. x1 is given to be here. So can it be greater than of the x1? What is x1? It's a 1. So this number is always be greater than of the 1, because root 7 is, what is the root 7? It's a 2 point something are there. It's greater than 1. Hence result is 2 for here. Assume the result is 2 for n is equal to k. Now I need a 6 plus something, so I can adding the 6 on the both side and then take the square root of this. So what will happen? This is my here. So therefore by the principle of the mathematical induction, the result is 2 for all this n belongs to the natural number. Hence it's a monotonic increasing sequence. Now look at the third kinds are there. So in this case your target is to check what is the nature of this sequence. It is given that both the an is greater than 0, bn is greater than 0, but they are not talking about that whether an is this or an is less than of this. This is not given to you. So what we can do, I assume that a1 is greater than of the b1. You may assume that a1 is less than b1. It's on your choice. So let's start with this. So firstly we can take n is 1. So what will happen? It is my nothing but b2 is root of this. What is the meaning of that? It's a geometric mean. This is called as geometric mean. So we know that if it is a geometric means, it means this b2 must lies in between them, and we know a1 is greater than of the b1. So I can write as b1. Here is a1 and b2 lies between them in this manner. Similarly, I can substitute here. We will get as n is 1, it means a2. It is an arithmetic mean. So a1 and b1. So a1 is bigger than of this. So a2 lies in between them. This is a sequence. So from here and from this, I can say b1 is less than b2, but b1 is less than a2 also. So it means our target is to find the relation between them. So what is the b2? b2 is the geometric mean, a2 is the arithmetic mean. What is the relation between them? We all know about here. So from this and from this, what you conclude that b1 is less than b2, b2 is less than a2, a2 is less than a1. Similarly, if you take n is equal to 2, if you can calculate here, it's my b3. b3 is nothing but a2 b2. What is the meaning of that? It means b3 is the geometric mean of this. And what is the relation between a2 and b2? We can see here. a2 is less than of the b2, so b3 lies between them. Similarly from here. Hence, arithmetic mean is always be greater than of the geometric mean. So from these three relations, we can get as of here. So similarly, if you extend them, what will happen? b1 less than b2 less than b3 and so on. Here is a1 and so on. So what is the meaning of that? You can see bi sequence is my monotonically increasing sequence, while ai's are my monotonically decreasing sequence are the required answers. Look what the similar nature are there. So again, x0 is given to a and a is my positive number. Check about the sequence is increasing. So what is given to you? x1 is given to you here. Look at that. A is my positive number. So a is positive. So x0 is my a. So it is also the positive number. B is my positive number. So all are my positive. So that means this number is my greater than 0. Also, we can say x1 is greater than of the a. A is nothing but my x0. That means x1 is greater than x0. Also we know that because all these numbers and these are my positive. So secondly, if you take about the x2, so look at that, x1 is my positive, x1 is a, b, all are my positive, so this is my greater than of the a. So what is the a is x0, or you can say this number is my greater than 0. Now once you know that, assume xn is also the positive. So what you say, xn is positive, an is positive, so this is my positive. Now in order to check whether it's increasing or decreasing, we can start from here. So if you take the LCM, you will get here, when it will be greater than 0. It will be greater than 0 only when xn is greater than of the xn minus 1. So that means this sequence is monotonically increasing only when this condition satisfied. Look about the another one. Here again of this kind, you have to target of this. x1 is greater than 0, y1 is greater than 0 given. But what is the relation between them? Either this or this. It is not given to you. So I assume that x1 is greater than y1. So once here you can substitute this value. Firstly, I can take n is y1. So what is that? This is 2x2 is x1 plus y1. What is x2? x1 plus y1 upon 2. What is the meaning of that? What is the meaning of this? This is x2 is the arithmetic mean and y2 is the harmonic mean. And since x1 is greater than of the y1, I can write like this. So what is the meaning of that? x1 is greater than of the y1 and arithmetic mean always lies in between them. So we can write like this way. Similarly for here. What is the relation between the y2 and x2? We all know arithmetic mean always greater than of the harmonic mean. So here. So can you combine these three? You can see x1 greater than x2 from here. x2 greater than y2. y2 greater than y1. Similarly, if I take n is my 2 for the second case, we can substitute here. We will get x3 and the y3 as the arithmetic mean, geometric mean. As we see, x2 is greater than y2, x3 is the harmonic mean, arithmetic mean, and is my here. So from this again we can deduce that as harmonic mean is less than of the arithmetic mean, we can get here. So clearly says x1 is greater than x2, x2 greater than x3, we can combine them. Here we can see this. Similarly for the y component, and in the similar manner we can get as this sequence. Clearly says that xi is my decreasing sequence and yi are my increasing sequence. Look about the another one. So again you have to check the monotonicity of the sequence. So clearly says that if you take s1 and s2 both are positive, but again either this happen or this happen, you can take any one of them. So let's say in this time I consider this one. So if I take n is my 1 in here, you get s3 are this. What is the meaning of that? This is nothing but my geometric mean. So once s3 is my geometric mean and s1 is less than of the s2, I can write here. Similarly, if I consider another one, s3 is less than of this, so for n is equal to 2, I can substitute here this. So what is the meaning of that? This is my geometric mean of s2 and s3. So s3 is less than of s2, I can write s4 in between them. So can you write the combine of this? Yes, you can do. s3 is less than of the s4 is less than of s2. Similarly, you can extend them. You can see this is the 1, is a 3, then 5 and so on, and it is here. So it means the odd sequence is my increasing while the even sequence is my decreasing. Look what the another one are there. So in this case it is given that s1 is my positive, s2 is greater than s1, which is positive again. So look at that, it is already mentioned that s1 is less than s2. So we can firstly reformulate them. I can rewrite this form as of this. What is the meaning of that? Now if I consider n is my 1, substitute here. because if you take n=1 it will be 0, but s0 is not defined, so we can start from 2. So if I substitute here, s1 is less than of this. So what is the meaning of that? If I take of this s n3, this is corresponding 3, because 2 is itself a 0, this is my here, so that's a harmonic mean, this one. Again, s3 is less than of the s2, from here we can get as s4 as a harmonic mean, and so on. Can you combine them? You can easily combine them. s1 is less than s3, less than s4, less than s2. Similarly, we can generalize them and we can get as the monotonic increasing and decreasing sequence. So this is the way you can check about the monotonicity of the sequence in a very simple manner. We will see the next lecture on the bounded above and the bounded below sequence, again with the help of the 10 to 15 examples. Till then, you can simply like, share and comment this video with your friends. Best of luck, students. Happy learning.